So we're going to be looking at inverse Laplace transforms, but before we do that, I want to do a quick review of partial fractions. So first, distinct linear. So if I have 1 over x squared plus 2x minus 8, we're going to break those apart by factoring the denominator. So x squared plus 2x minus 8 factors to x plus 4 times x minus 2. And then each factor we break apart. Now because there's linear factors on the bottom, we just need constants in the numerator. So we clear our fractions by multiplying through by the LCD, which is x plus 4 times x minus 2. So every single factor is being multiplied by that. When I distribute over here, everything cancels, so I'm just left with a 1. When I distribute here, the x plus 4's cancel, so I'm left with a times x minus 2. And then the b times x plus 4. And we have to solve for a and b. So I'm going to let x equal 2. This term goes to 0, and I get 6b. So b is equal to 1/6. And then I'm going to let x equal negative 4. So this term goes away, and I get 1 equals negative 6a. So negative 1/6 is equal to a. So our partial fraction decomposition is negative 1/6 over x plus 4 plus 1/6 over x minus 2. So distinct linear factors is the first case. We can have repeated linear factors. So here I have x plus 1 over x times x plus 3 squared. So when we break it up, we have 1 x in front. So it's just a over x plus b over x plus 3 plus c over x plus 3 squared. We have to take into account all possible combinations. So again, do the same thing, multiply it through. We get x plus 1 equals a times x plus 3 squared plus b times x plus 3 plus c times x. I'm going to let x equal negative 3. And when I do that, when I plug in negative 3 here, I get negative 2 equals, this term goes away, this term goes away. So I get c times negative 3. So 2/3 is equal to c. If I let x equal 0, then over here I get a 1. This term goes away, and this term goes away. So I'm just left with the 1 in here. I'm sorry, 3 in here. So 3 squared gives me 9. So I get 1 is equal to 9a. And 1/9 is equal to a. Now there's nothing else that makes the terms go away. So I'm just going to randomly just pick a number, x equals 1. So when I plug that in to the x plus 1, I get 2 here equals a, which is 1/9, times 4 squared, plus b, which I don't know yet, times 1 times 4, plus c, which is 2/3 times 1, just gives me 2/3. So we can just plug that into a calculator. and I got negative 1/9 is equal to b. Oops. So for this one, it's 1/9 over x plus a negative 1/9 over x plus 3 plus 2/3 over x plus 3 quantity squared. So that's our case for repeated linear factors. And then I want to look at quadratic factors. So we have 3x minus 2 over x cubed times x squared plus 4. So that x squared plus 4 can't be factored. So when I break this apart, I have repeated linear first. So I have a over x plus b over x squared plus c over x cubed. And then because I have a quadratic in that x squared plus 4, then I have to take into account any linear factor in my numerator. So that has to be dx plus e. So clear the fractions. We get 3x minus 2 equals a x squared plus 4 plus b x squared plus 4 plus c x squared plus 4 plus dx plus e times x cubed. So I'm going to do a little bit different method for this one because it's not quite as simple as just plugging in the things that make it 0, because the only 0 I have here is 0. So that's not really all that helpful. So I'm going to multiply things out and collect like terms. So distributing here, I get a x to the 4th plus a times 4 times x squared plus b x cubed plus 4 times b times x plus c x squared plus 4c plus dx to the 4th plus e x cubed. Alright, so now I want to kind of group things together. If I notice on the other side, there is no x to the 4th term, there is no x cubed term, there is no x squared term. So when I group those together, the coefficients have to equal 0. So starting with the 4th degree terms, I have an ax to the 4th and a dx to the 4th. So 0 equals a plus d x to the 4th, which means a plus d has to equal 0. And a is just going to be the opposite of d. And once I find that, I'll go back and substitute. Then I'm looking at my cubic terms. I have bx cubed and ex cubed. So 0 equals b plus e x cubed, which again means b plus e has to equal 0. So b is just the opposite of e. Then I'm looking at my x squared terms. I have 4a x squared and c x squared. So 0 equals 4a plus c x squared. So 4a plus c has to equal 0. So c is equal to a negative 4a. Or you could have said a is negative 1/4 c, however you want to rate it. And now I'm getting to some that I actually have coefficients for. So now I'm up to my x terms. So if I look at x, I have 4b. So 3x is equal to 4b x, which means 3 is 4b, so 3/4 is equal to b. So that's my first solution that I actually have. And then for the constants, I have 4c, and that has to be equal to a -2. So -2 is equal to 4c, -1/2 is equal to c. So now that I have these, I can build out the rest. A is going to equal to -c/4 from this. So A is equal to a -1/2 divided by negative of -1/2 divided by 4, which is just 1/8. So I have A, B, and C now. D is just going to equal -A from up here. So D is equal to a -1/8. So I have that. And then the only thing left is E. And E is equal to a -B. So E is equal to a -3/4. So I have all the pieces, and then you can just put them back up over each fraction.